So the only difference in free-falling object, if you want to rewrite the equations, you're not really moving the x direction. You're moving in which direction? The y direction, right? And your acceleration is always going to be what? Negative 9.8, gravity. So that's the only difference. So if you want to rewrite these equations, you can say, you know what, equation 1 now, I don't want to use x, I'm moving in the y direction. I can say y equals y0 plus v average times t. Instead of x, use y. Second equation, v equals v0 plus. Remember, the acceleration for gravity is what? Negative 9.8 meters per second squared. And instead of a, they might use g. So they'll use the letter g, which is the acceleration. That's gravity. Equation 3, let's look at this one. Every time you see x, put y. Every time you see a, put g. So here we go. X, you change it to y, and a, you change it to g in these equations. So equation 3 becomes what? Y equals y sub 0 plus v0t plus 1/2 gt squared. And the last equation, v squared equals v0 squared plus 2g times the change in y. So these are my 4 equations. The same 4 equations we used before, we're just changing it. Changing x to y, and we're changing a to g. Here's an example. We have a tree here, lemon tree, or fig tree we said, has all these figs on it. There's a fig here. And the fig actually falls down to the ground. Initially the fig was 3 meters high. Fell off the tree, and it's on the ground now, as the fig. Fell to the ground. Question number 1. How long? So time-wise, it took the fig to get to ground. That's time-wise. And 2, we should ask maybe the speed of the fig just before it hits the ground. What was the speed of that fig just before it hits the ground? Again, there's a lot of information in that problem, just hidden information. Such as what? What do we know? I know the initial height. How high was the fig initially? 3 meters, right? I also know the final height when the fig hit the ground. How high was above the ground when it touches the ground? 0. I also know gravity, which is what? Negative 9.8. What else do I know? I know the initial velocity. This was on the tree. How fast was it moving? 0. Can I find the time? Is there an equation right here that has these pieces in it? Someone said the first one? I don't know what the average velocity, right? You say, well, you can find the average velocity. The average velocity is 1/2 v final plus v initial, not minus plus. The problem is I don't know what the final velocity. So I really can't use this because I don't know what that average velocity. I can't use this because I don't know the velocity or the time. How about the third one? Y equals y sub 0 plus v0t plus 1/2 gt squared. So let's plug in what do we know? Do we know what y is? 0. Initial 1, 3. What was the initial velocity? 0 times anything? 0. Plus 1/2 times negative 9.8 times t squared. 0 equals 3 minus 4.9 t squared. Move the negative 4.9 to this side, becomes positive. T squared is equal to what? 3 divided by 4.9 is 0.6122. That's t squared. Can you find t? Take the square root of that number. 0.7824 or 5 second. Can we find out how fast was the fig going before it hit the ground? Let's see. I can use any of these equations. I can use this velocity equals v0 plus gt. My initial velocity is 0. Gravity is negative 9.8. And the time is what? 0.7825. So what is my final velocity? It's negative what? .67 meters per second. Why is it negative? What's the negative means? Moving down. Up is positive, down is negative. So the speed right before it hits the ground, it's moving at speed. If they ask you for the speed, by the way, the speed is always the absolute value of the velocity. It doesn't have negative or positive. We're just looking for the value. It's 7.67 meters per second. So if they say, what's the speed? Pay attention to that. They don't want a negative or positive with it. Speed is always positive. It's the value. How fast is it moving? They don't care which direction. Velocity is a vector. The minus sign tells you it's coming down. Let's try another example. I've been listening to the news about Hawaii with the volcano eruption there going on. So let's do an example like that. So we have a molten lava that's flying up in the air. So the eruption is you get a piece of lava, boiling hot, goes up in the air, then it comes down. Let's assume, because they can't really get to that, close to that, because it goes straight up in the air, then it comes back to the same spot. So let's assume the time it took, they measure the time, from the time it was launched or took off till the time it came back, it took 4.75 seconds. The time to rise and fall back, we'll just write it down. The time to rise and fall back, both combined. We said that time, I said that time is equal to what? 4.75 seconds.
I can't see it.
Oh, can you see it?
Yes.
And the question here, simple. What's the initial speed? Find V0. That's all I'm giving you. If it took 4.75 seconds to go up and down, then to go just up, how much time does it take? And how much time does it take to come down? Half. So what's half of 4.75? 2.37. Second to go up, 2.37 second to come down. As I said, with these problems, free falling, a lot of the stuff is given to you, but indirect way, you get a fish for it. When you reach this point, when the lava reaches that point, what is the final velocity up there? 0. Because if it has any more speed, any more velocity, it will keep rising. So let's write what we know. We know initial speed is unknown. We're looking for it. We know the final velocity, 0. We know the acceleration, gravity, negative 9.8. You want to use 9.81, that's fine. We know the time it took to go from here to the top. Since I'm talking about the final velocity being 0, I'm talking about just that travel from here to there. That time is what? 2.37. Is there an equation we can use there that will have all these in it? Which one? Second one?
Yeah.
I could, yep. So V equals V0 plus GT. V0 equals V0. What's V0 here? Unknown. Minus 9.8 times the time, which is 2.37. V out is going to be what? 9.8 times 2.37. Initial velocity is 23.226 meters per second. It's 52 miles per hour, comes out of the ground. Curiosity, I'm just wondering about this problem. How high would it go? That lava. What's the maximum height? Find V out and maximum height. How high is it going to go? Can I find y? I can use probably this. Y equals y sub 0 plus v0t plus 1/2 at squared, right? Or gt squared. Y is unknown. If I make this as my reference, I'm going to measure the height from this point. That's my reference. That's my zero height. My initial velocity is 23.226 times the time, which is what? 2.37 plus 1/2 times gravity, which is negative 9.8 times 2.37 squared. (23.226) times 2.37 minus 4.9 times 2.37 squared. I got, if I push the right button, 27.5 meters. That's how high it's going to go.